get started? Good, it is. So we are adding and subtracting basic rational numbers today. That's fractions and mixed numbers. So what I need you guys to do is draw a line down the middle of your paper. Maybe not down the middle, maybe like 2/3 or 3/4 of the way to the right-hand side. Yeah, vertical line, just straight down the middle there. That way, you can write notes to yourself, or while we're doing these problems, you can do the I do one on one side and the you do on the other. So you need to be in our notebook right now, where you titled that notebook page with the same title as this. So I'm going to be writing notes to you in the middle here. That's what you're going to put on the right-hand side of your page. So the kind of the steps of what we're doing, okay? And the steps. That's what we're going to do. Why isn't this focusing like I want it to? I need to move this away. Let's try this again. There. Okay. So what, like I said, when I write the little notes to yourself, that'll go on the right-hand side, and then the problem will go on the left-hand side. So, adding fractions, we did this already. We already did this on your homework. So the first thing we want to do whenever we add fractions is we want to find the LCD. Who remembers what an LCD stands for? Riley. Good, so get an LCD. That's least common denominator. Now, some of you guys know this method called the butterfly method. I would recommend not using that method. That will be nice, that will be fine for this one, but it will not be fine for the next one, the one that says you do. The numbers get too big and you don't have a calculator. You're not allowed to. What is that LCD? Yep, Nevaeh? 35. 35, good, because 7 and 5 both go into 35. So now what I have to do is I have to scale the fractions, right? So scale the fractions. What that means is I have to make it so that their denominator becomes 35. Scale the fractions. So that step looks like this. I'm going to multiply the right fraction by 5 over 5, because that will give me a denominator of 35. And then I scale the left fraction by multiplying by 7 over 7. Sometimes it doesn't let me. There we go. Sometimes on the left-hand side of my screen, it doesn't let me actually draw. See? Ready? See it? And, sweet, it stayed. So I scale those fractions, and I get 7 times 3 is 21 over 35. 4 times 5 is 20 over 35. And now I just add. 21 plus 20 is 41 over 35. That's an improper fraction, so sometimes we can leave our answer like that. Sometimes we can leave our answer in improper fraction form, and sometimes we need to simplify it to a mixed number. So simplify if needed. What that means is just do the division. That's what that means. Do the division. I know, it's distracting. Just do your best to not get distracted. Just do the division. Okay? So how many times does 35 go into 41? One time. And what do we do with that remainder? As the top. The top is called a numerator. Yep. So then the leftovers become the top. Or the numerator. Okay? So, I've got one for you to do now. You do this one. Right? You do that one. Go through the steps. I'd recommend first finding the LCD. Butterfly method, people. 9 times 12, you really want to do that? You really want to multiply numbers times 12 and times 9? Don't do the butterfly method. It's not in your best interest. It is a bad method. LCD equals 36. I know. Just do your best. Nothing we can do. Yep, December is when the construction's over.
What?
You'll get used to it, I'm telling you.
Wait, the library?
Mm-hmm.
Where I thought it was
I thought this was January.
you said January.
Same idea. January, December, how different is that?
It's gonna be done in December, but we're not gonna.
You won't be here. Okay. Are you guys working on this one? Getting it done? numbers. Scale the fractions. Scale the fractions means multiply by what you need to multiply to get the least common denominator. I always think, like, why couldn't we have hired a crew that maybe worked second shift? And maybe just spitball in here, you know.
Or first shift.
Just an idea. Second shift is the 3 to 11 shift. First shift is 7 to 3. Reminds me of a country song. 7 to 3, 3 to 7, 3 to 11, 11 to 7. It's called shift work. That's the name of the song. All right, as we were. Here we go. Questions on this one? Great, let's move on to mixed numbers. Draw a line across the middle. Draw a line across the middle now. Now you know that this next one is adding mixed numbers. So same steps as adding fractions, but the first step is not going to be you find the LCD. The first step is stack them vertically. Stack them vertically. All right, so my recommendation is to write it out like this. 3 4/5 plus 4 1/2. You'll see why in a moment, why I think it's helpful to do that. You don't have to, I find it helpful though. Now I need to get the LCD just like normal. So, LCD. What is the LCD here? This one's a pretty easy LCD, it's 10. Right, 5 times 2, 10. So now we need to scale the fractions, right? Scale the fractions. When I say scale the fractions, I don't mean like climb a mountain. Like scale the mountain. Scale means to increase the size or decrease the size. That's what scaling means. Guys, you know that like a model airplane is to a certain scale, or like a Matchbox car is to a 1 to 55 scale, meaning that if you multiply all the dimensions of a Matchbox car by 55, it will look like a real car. That's a scale. Things that are modeled. We'll talk about scale in a little bit. End of November, December, somewhere around there, we'll talk about scale. So we need to scale the fractions. I need to multiply the top one by 2 over 2 and the bottom one by 5 over 5. And I get 3 and 8/10, 4 and 5/10. Okay, next step, add fractions. What do you think's coming after add fractions? Add the whole numbers. Good. So we want to add the fractions, then add the whole numbers. So I add the fractions. 8/10 plus 5/10 is 13/10. Add the whole numbers. 3 plus 4 is 7. Now, many of you guys can see we have one more step to do. Yep, Josie? 8 and 3/10. We have to simplify this. So what Josie is getting at, we want to carry to the whole number, right? So carry the whole number. So she said, so when we carry the whole number, that means how many times does 10 go into 13? 1 time, so we need to tack that 1 onto the 7, right? So it becomes 8. And then how many is left over? 3/10. All right, here's the you do. You do this one, checking your work with your partner. My wife calls these hot dog notes. She actually has people fold their piece of paper in half, and then on one side you do it, and then on the other side she does it. If you follow the steps, stack them vertically, find the LCD, scale the fractions, add the fractions, and simplify. now we need to stack up virtually. And then we need to find the LCD, so follow those steps. Well, right now, the whole thing is called adding. We need to follow those steps. The LCD is the least common denominator, so remember this, find the least common denominator. So we have 15 and 6 point one two. Find the LCDs. So I don't teach finding LCDs because that's you learned that already. Okay. Six and 15, butterfly method. Don't want to do that one. 6 and 15, that's way too big. 6 and 15 both go into 30. 30 is way easier to work with than, I don't know what 6 times 60? Nope, 6 times 15 is 120? I don't know what 6 times 15 is, I'll be honest with you. No, 6 times 15 is 90. Now, I don't want to work with 90. 90 is way too big. 90 is way too big. Yeah. 15 and 6 go into 30. If you don't know how to find the LCD, that's something you're going to want to look up on your own. Because that's a 6th grade standard. That's something you're going to need to look up on your own. Google how to find the LCD. Okay? So for right now, if you're still lost on the LCD, at least get everything else copied down so you can do everything else. Then on your own time this weekend, you'll need to Google how to find the LCD. Because that's a 6th grade standard, and I need you to already know it. All right, so here's one more you can copy down that will be on the notes. You don't have to do this one right now. We're not going to. But this is one that you can copy down and give yourself some space to do if you want another one to practice. This one will be on the online notes when I upload the completed notes to Canvas. This one will be. Okay. And moving on. Subtracting fractions. Draw a big line for subtracting fractions now. Let's I do, then you do. Okay, so I do first. What's the first thing we need to do? I need to find the LCD. What do both 20 and 4 go into? Yeah, they both go into 20. That one's a nice one. They both go into 20. So I need to scale my fractions, right? Scale them. So that means that I need to get my 1/4 to become something over 20, so I need to multiply by what? 5 over 5. I don't need to multiply my 20 by anything, but if I want to, I can multiply by 1 over 1. I don't need to.
Oh, it's not letting me draw.
You see that?
Yeah.
Can you guys see it? It's not letting me put it on there. Almost. So close. So close yet so far. Oh, yes, I got it. I just draw at a weird angle. I can do 1 over 1. If I want to make sure I'm scaling both of them to keep my pattern the same, I can multiply by 1 over 1. I don't need to, but you can. So now this ends up being 9 over 20 minus 5 over 20. Now luckily I don't have to carry anything. I don't have to borrow, which is nice. Also, this isn't a negative. This isn't going to be a negative. What if it was the other way around? What if it was 5/20ths minus 9/20ths? Yeah, because same sign add, different signs subtract. We keep the sign of the bigger one. This one's bigger. 9/20ths is bigger than 5/20ths. Okay. But we're not. We're doing basic ones. Remember the title is adding, subtracting basic rationals. So no negatives today. Wow. Celebrations hurt sometimes. That's going to kill me someday. I better watch out. It's going to like concussion. All right, so then this ends up being 4 over 20. So we subtract. Right, so you just subtract your numerators. When you subtract, you only subtract numerators. And then 4 over 20, 4/20ths, is not simplified. So the last thing is simplify if needed. What goes into both 4 and 20? 5. Try again. 4 goes into both 4 and 20. So 4 divided by 4 is 20 divided by 4 is 5. 4/20ths becomes 1 thing. Okay? Make sure you have those steps written down for your you do. This is a you do. I did one, now you do one. Look how nice that was. LCD. That's a hint to you for the LCD, right? On the video, I'm going to cut out all of the waiting time. I guess I don't need to cut out the waiting time. You can just fast forward, can't you? Because we got some people who are absent, so they might want to watch the video this weekend so they can come to class prepared on Monday. You know? Well, I mean, that way on Monday they're not so lost. You know? That's the cool thing about being absent is that if you come back, you're really lost. Because not only did you miss a whole day, now you're confused for the new day. So then if you miss one day, really you're behind for a couple of days. So that's why I post the videos. So that way, hopefully at least you can watch the video when you're at home sick or something like that. And maybe you can come to class the next day at least having an idea of what you missed. We should be almost done with this one by now, just so you know. This one's a pretty fast one, isn't it? This one was pretty fast, wasn't it? Because we only had to scale one fraction and then it was easy subtraction. Okay? And there was no simplifying, was there? I did that on purpose because this one is going to be a little bit more time consuming. Okay? Sometimes when you subtract, you have to borrow, right? We saw that on the quick quad. Yeah? Borrowing with decimals is different than borrowing with fractions. It's the same idea. You're borrowing one whole value. But with decimals, one whole value is always a factor of 10. When we borrow with fractions, it's rarely a factor of 10. Okay, so let's go through the steps. Same first step as last time. What was the first step for mixed numbers last time? You wrote it down.
Find the common denominator.
That's the second step.
Find the LCD.
That's the same as the least common denominator. Stack them. Now, you do not have to, but I would recommend it. It is a lot easier to subtract when they're stacked up, right? Let's be honest, how long have you done column subtraction? You subtract, you put them one on top of each other, right? Isn't that kind of what we've done for a while? So keep it consistent. So you stack them up, and you get 4 1/2 minus 3 3/4. You want to know what the number one mistake people make is? It's not the LCD. It's not scaling the fractions. Subtracting. That's the number one mistake. They line them up and then they add. No joke. It's the number one mistake. Don't make that mistake. Don't be like everyone else. Be unique. Subtract. All right. Once you've done that, now we need to find the LCD, right? Stack and find the LCD. LCD for this one, it's not 8, it's 4. Okay? So when I do this, to get this to be 4, I go 2/2, and then I don't need to do anything for the other one, 1/1. But I don't have to write 1/1. I can, but I don't have to. So now that equals 4 and 2/4 minus 3 and 3/4. I have a dilemma here. If I'm going to subtract, I subtract fractions, right? 2/4 minus 3/4 gives me -1/4. Well, I can't do that right now because I have these mixed numbers. So what we need to do is we need to borrow. Okay, so we need to borrow from the whole number. Borrow 1. Notice I put the 1 in quotes. I did that on purpose. Borrow 1 from the whole number. In decimals, 1 is 10/10, right? We talked about that already on the quick quad. What's 1 whole number? What's 1 in this fraction? 4 what? It's not tenths, right? It's not 10 tenths. What's 1 whole here? 4 fourths, because our denominator is fourths. 1 whole value is 4/4. That's what we're going to borrow. That's why we're borrowing 1 from this from over here. We're going to borrow 4 fourths. And what we do next is we add, so the idea is add the denominator to the numerator. Add the bottom to the top. That's another way to think about it. So when I borrow, I want to borrow 1 from the whole number, and this becomes 2 plus 4, which is 6. Where'd the 4 come from? Because 1 whole value is 4 fourths. 4/4. So 2/4 plus 4/4 is 6/4. Now I can subtract my fractions. Subtract fractions, subtract whole numbers. Six-fourths minus 3/4 is 3/4. 3 minus 3 is, so of course my final answer is then just 3/4. All right, here's your you do. This one's tricky. Feel free to talk to your neighbors about the steps. Make sure you just follow the steps. If you need to borrow, borrow. If not, great, you don't have to. What's our LCD? Good, I tried to make the LCD easy for this one, to make it a little bit easier. What do you think the answer should be close to? 6 1/9 minus 1 4/27. What do you think it should be close to? Should be close to 5, right? So when you get your answer, it should be pretty close to 5. So we always want to estimate to make sure we're on the right track. So you should be attempting the you do using the steps we wrote down. This will be the last problem we do. With the denominator of 27, what's one whole value, in quotes? What's one whole value with the denominator of 27? 27/27. Exactly, 27 over 27. That's when you borrow one whole value, you're borrowing 27/27. You should be attempting this one as I do, you do, not I do, you wait for me to put the answer up and copy. Is I do, you do. I want you to get it wrong or get it right, but either way, I want you to get it. When you're done with this problem, look up. The LCD is 27, right? Which part? What's the LCD between 29 and 27? What's the least common denominator? 27. So what do you need to do for this one? You scale it up, right? So how do you scale 6 and 1/9 up to be something like 27? Multiply by 3 over 3, because what's 3 times that? Okay, so that's what you need to do. And then you get, notice the blue writing is 6 and 3/27 minus 1 and 4/27. All right, so follow the writing here. We stack them up, stack them. Our LCD is 27, so we need to scale the 1/9 to be out of 27. We scale it by multiplying by 3 over 3. Now we've got 6 and 3/27 minus 1 and 4/27. Can't do that. So we need to borrow. We borrow 27, as we were told, 27/27. 3 plus 27 is 30. So 30/27 minus 4/27 gives us 26/27. And we subtract 5 minus 1 is 4. Is this close to our estimate? Did we say it should be close to 5? 4 and 26/27. That's 4 and almost 1 whole, right? So that's very close to our estimate. Okay. Here's one other problem that if you want to do this one as an additional practice, I'd get it written down. This one will be on the completed notes on Canvas. For the video, I'll just show the answer real fast. You can pause it on the video and take a look.